Hi, I'm Arisman Saleh and I'm from the Forest Research Institute of Malaysia, FRIM, under Pulp and Paper Laboratory. Before we start, I would like to express my highest gratitude to my lab colleague. This is an honor for me to represent them. I also would like to thank you to MTE committee for giving me a chance to participate in this great event. Now, I would like to present our innovation, biodegradable face mask from lignocellulosic material and nanofiber. This is our presentation outline. We will start with the introduction on why we propose this product. Then we will move on to the mechanisms of the invention. Next, we will see the fabrication process and then some preliminary results that have been tested on the product, and then the future work, and finally questions and suggestions from the audience. As we know, the global pandemic COVID-19 had affected us in many ways, from healthcare, economy and social system. One of the new norms that we must adapt to is the usage of face masks. Face mask is used to prevent the spreading of the virus, and it became compulsory to be used in all public places in Malaysia. Most users use disposable face masks, which resulting tremendous amount of face mask waste. According to Dr. Tang Yi Chong, a Malaysian waste expert, 10 million masks are being used and discarded daily in Malaysia, and the number could even more. To make it worse, as for now, Malaysia only has landfill system for disposal of public waste, and plastic waste will remain in the landfill for a long time. Some will eventually end up in the ocean and is catastrophic for the sea life. In this project, we fabricate a biodegradable face mask from lignocellulosic material, a kernel fiber and a nanofiber related cellulose, and a nanofiber. We believe this innovation at least could spark a change in environmentally friendly face mask production. In this slide, I will explain how our innovation works. Basically, it works as a common three-ply face mask. It has three functional layers. The first layer was made up from composite of kernel fiber and nanofiber related cellulose, NFC. The first layer undergoes surface modification using a sizing agent to improve the hydrophobic properties. This property is important to make sure that the layer can repel any moisture that landed on the layer. The second layer was a nanofiber mat. By using electrospinning machine, we fabricate a nanofiber with a nano-sized diameter so that we can filter dust particle, bacteria or even virus itself. For instance, the size of coronavirus is around 50 nanometer to 140 nanometer, and this nanofiber can filter the virus efficiently due to the nanoscale diameter. Moving to the third layer, it is the same with the first layer but without surface modification to ensure the layer can trap any moisture from the face mask user. Now I will explain the fabrication process. We will start by fabricating the first and the third layer. By using simple paper making step, we fabricate a thin sheet of kernel fiber and NFC. The thickness of the single sheet was around 0.05 mm. It works as a first protective layer and supporting FRIM. The presence of NFC was to improve the mechanical property of the layer. Then we use sizing agent to modify the surface. This modification turns the original hydrophilic, a water-like behavior, into hydrophobic, a water-repellent behavior. This step is crucial as we know that the coronavirus spreads through the air droplet. The third process was electrospinning, and for this process, we are using biodegradable and safe polymer, polyvinyl alcohol and guanidine. Electrospinning is a process that manipulates the difference in voltage supply to the polymer solution, resulting in nanofiber. This nanofiber mat has a mean diameter around 200 nanometer and exhibits good antimicrobial properties. This property is an important feature to the face mask to function effectively. We did a few tests to this innovation to ensure it can work properly according to the global health standard. So we have a scanning electron microscope SEM imaging for the layer characterization, this diffusion assay to check the antimicrobial properties, natural soil burial testing to test the degradability and penetration particle test to test the filtration efficiency. The first SEM image was the first and the third layer. The second image is from the second layer, middle. So we can see the second layer has a finer nanofiber with a mean diameter of 200 nanometer. Secondly, we did the disc diffusion assay or DDA. In this assay, we tested the second layer for the antimicrobial properties with 5 bacteria. We grew the bacteria on top of the layer sample. The result showed that the sample showed good bacterial inhibition property in 4 out of 5 bacteria. This indicates that the second layer has a good antimicrobial properties. The next test that was done was the natural soil burial test. In this test, we buried the biodegradable face mask and calculated the weight loss. We compared it against the commercial face mask. The result shows that biodegradable face mask lose almost 80% of its original weight compared to commercial face masks, which only lose around 23% for 21 days. Lastly, we did the particle penetration test to the mask. This test was done in collaboration with National Institute of Occupational Safety (NIOSH) in Bangi. In this test, 0.3 micron paraffin oil was sprayed onto the mask using TSI high flow automated filter test. The biodegradable face mask can filter 99% of 0.3 micro paraffin oil, and this indicates that the mask has high filtering capacity. With all the promising results of the test, there are no doubt that this is the way of the future. However, we have a lot more work to be done to make it into a final marketable and effective product. Basically, what we have done here is only focusing on the main mask material. We have not done the research on other parts of the mask, such as the ear loop and the nose strip, to ensure all elements of the face mask are degradable. We also plan to further improve on the design model, specifically to fit Asian face, to ensure the face masks work properly and efficiently. Thank you for your time. Feel free to contact me at norarisman@frim.gov.my regarding this project. Together, we can create a better tomorrow.